Hello, welcome back. Today we're going to take a look at how we find the angle between two planes. So I have two planes drawn here, and we want to find this angle right here. Now the only problem is it's really hard to find the angle between two planes when they intersect. So instead, what we're going to do is we're going to draw two norms from our plane. So if you've forgotten what a norm was, that's pretty easy. That is the vector perpendicular to the plane. So if I draw a perpendicular vector from the plane here and one from the other side, eventually they're going to run into each other. Now, this will help us find the angle because we know how to find the angle between two vectors. And that was easy. We did that earlier, right? The angle, right, between two vectors, right? And we had this rule. Inverse cosine of, well, we need lines here, right? So if I call this vector 1, norm 1, and this one norm 2, right? We would take the dot product. N1 dot that with N2, and then divide by their course, then we would divide by the product, of their magnitudes. Now, you got to be really careful with the rule here. What we're really going to find is this angle. Now, thanks to geometry, I know that this angle won't equal up here. I can even look at this. Looks obtuse and this looks really acute. I can just kind of see that. But thanks to geometry, this angle right here will actually be this angle that we want. We'll call that one beta. We're actually going to find this angle right here. But the angle we want is really right here, theta. But if I know this angle, which is going to give me the angle between my two vectors, we know that because of the direction of our arrows. Remember, direction is very important when you're looking for the angle between two vectors. You want them going in the same direction, either both away from each other or both towards each other. So we're going to get this angle right here when we do our computation. But because we want this angle, we can just use the fact that it's a linear pair. Take the 180 minus beta. We'll talk about that in just a few moments. So let's take a look at how we find the angle between these two planes right here. I got this plane x minus 2y plus z equals 0 and 2x plus 3y minus 2z equals 0. And I want to find the angle between these two planes. Well, first things first is I'm not going to be able to find the angle between the two planes, so I use their norms, which we just set up here. So if I find the norm 1, oh no, how do we find the norms, you might ask? Well, that comes from the coefficients of our plane. And that came from a while back ago when we learned how to write the equation of a plane. We had used the dot product of the directional vector and a point on the plane itself, and we got this direction, and we got this perpendicular vector. So the norm comes from the coefficients. So for n1, I'll use this as 1. My norm would be 1, negative 2, 1. And this would be my vector perpendicular to one of my planes. To get norm 2, I use the second coefficients, 2, 3, negative 2. And then I just do the math on it. Ready? Cosine of theta equals 1. The dot product between the two, so I take 1, negative 2, 1. Dot that with 2, 3, negative 2. And divide that by their corresponding the product of their magnitudes. Dang, keep on saying corresponding. Sorry about that. So we get 1 plus 4 plus 1, square root of 6, times the square root of, 17. And in simplifying this one, we would get 1 minus 6. Oh, sorry, that should be 2 minus 6 minus 2 over the square root of 102. So therefore, we can get theta by taking the inverse cosine of negative 6 over the square root of 102. Now, I'm going to do that really fast in my head. I'm teasing. If you type that in your calculator, you're going to get 126.4 degrees. But remember, this really isn't the angle that we were looking for, so we really have to take 180 minus that. 180 minus the 126.4 degrees, and that gives us a whopping 53.6 degrees right there. And that's really the angle we were looking for. Some people argue, but you weren't specific. Find the angle between two planes. So, hey, have both of them. So if we have these two planes intersecting, one's going to be 126, one's going to be 54 degrees. So I hope you enjoy this. Come back for part 2, and we're going to talk about how do you find the distance between a point and a plane.